So yesterday, well, Wednesday, we talked about central angles. So example 1's kind of a review. We're going to add on to all the different kind of angles that we look at within a circle today. Okay, so if you have a highlighter or a colored pencil, today's kind of the day to use it too. So for example 1, let's find the measure of the following angles or arcs in circle E if HF is a diameter. So this is kind of a review. So how do you think, what's the measure of angle FEJ? This angle right here. 125? Remember, a central angle and the arc are always the same amount. So if the arc's 125 from F to J, and the angle, central angle is 125. What about GEF? This angle here. Now this one's tricky. But remember, HF is a diameter. So HF cuts the circle in half. So if GH is 101, that means this is 101. Which would make FEG how big? Close. 79? Because together they would have to make 180 because it's a half a circle. So this is 79 degrees. JEH would be our last angle here. Now there's a couple ways to figure that out. You could use the 180 rule again. You could, or how many degrees are there total in a circle? 360, so I could take 360 and subtract all three of the other ones. Because the whole circle's got to be 360, and we're only missing one part. So this last one's 55. Okay, now that we have the measures of all the angles on the inside, we can find all the arcs on the outside. So how big is just the arc JH? 55. It's the same as the angle. Thank you. And usually when the arc measure is there, it's on the outside. What about JF to G? From J to F to G. What would you need to do there? Good. Add 125 and 79. So 204. And then GHJ is the other half. G to H to J. So how big would that be? Just add up these two, right? So it'd be 156. Okay, so this all works because we have all the central angles. All the angles in the inside of the circle start at the center. The next kind we're going to look at is called an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So this is an inscribed angle. That angle D right there. Okay, everybody listening? The measure of angle D is not the same as the arc because it's not in the center of the circle. The measure of angle D is half the measure of the arc. So the measure of arc AB. Okay, I like to think about this one as like a flashlight. Okay, this is like your flashlight or a spotlight. This is your inscribed angle. right? A central angle would be more if it came from C. So this would be more of a central angle. Do you see, looking at that picture, how the two angles are different? The central angle here is much wider than the inscribed angle. So the inscribed angle is half. Okay, think about a spotlight or a flashlight. Isn't the light on the flashlight or spotlight much smaller than the whatever the things it shines on? So that's kind of what's happening here. It's the inscribed angle is half of whatever AB is. Okay, so if the measure of AB was 100 degrees, okay, the measure of angle of arc AB was 100 degrees. The measure of angle ACB, which is that central angle, is 100 degrees. But the measure of angle ADB, which is the inscribed angle, the angle that touches the circle, is 50 degrees. Okay, so it's always half. Think about it shining, the purple shining the light onto the pink. So it's making it twice as big. Okay, so let's look at an example. Everybody got that? So, in this first one, I want to find the measure of GHJ, this angle here. So you kind of look at what arc is it shining on. Now, sometimes it can get kind of crazy. So sometimes I bust out 2 Post-it notes and I cover up everything else. So this angle that we're trying to find is shining onto this arc. So the angle's got to be half the arc. Oh, we just kind of did that. So our angle measure is, what's half of 100 again? Yeah. It's 50. I can do the opposite. I can use the same thing. Instead of cutting it in half, I can multiply by 2. In B, I give you the angle measure, and I want you to find the arc. Instead of cutting in half, you need to double it. So the arc here is going to be 80 degrees. Okay, the tricky part about this section is that we throw all the different kinds of angles at you, and they can be kind of confusing. Whether it's the same, is it half, and then there's a crazy one at the end. So that's kind of what example 3 does. If you look, I basically have 2 inscribed angles. I got this angle S that's going to shine on RT, and I have angle R that's shining on QS. Okay, so we're going to find all the different parts. So let's just start simple. How big do you think angle S is? That's this angle here. It's an inscribed angle. 30, it should be half the 60 degrees. So just like we did on Wednesday, there's really not a whole lot of work to show for this. Just think, is it half or is it double? RS, by the way, is the diameter. So this is 30 degrees. Now, B says, how big is RQ? Oh, let's go to D next. They're in the wrong order. How big is arc QS? 74? Because you doubled the angle. Now I can figure out RQ. Before I couldn't, because RS is a diameter. So RS cuts the circle in half. So if from here to here is 74, this doesn't work. How big is it from here to here? What would you do, you think? What does half the circle have to be? 180. So you can take 180, subtract the 74, and you'll get what's left over. Does that make sense? So 180 minus 74, 106. So that's how big that side is. Before we even move on to the, well, C says TS. Can I now figure out how big TS is? What's the whole circle have to add up to again? 360. So if I have 3 parts of the circle already, I can find that 4th arc by just subtracting from 360. Yeah, so T to S is 120. So you got to use 360. You can use 360 to find missing parts, or I could have figured out, again, RS is a diameter, so I could have subtracted it from 180 minus 60. Okay, so there's multiple ways to do some of these problems. It's mostly visual. Now E and F we can just add. S, Q to R. So that's this whole side. That would just be 180 degrees because it's half a circle. This one gets tricky. T to S all the way around to R. There's 2 ways to do this. T to S to Q. JK. T to S. I don't know where I got R from. T to S to Q, which is right here. So really it's just these 2 pieces. Right, T, S, Q. So take 120 plus 74. $194. Okay, questions on that one? So you have to use what you know. You use the diameter, cuts it in half, makes it equal to 180. Use the fact that the whole thing's 360. Using the inscribed as half the arc. When you have 2 inscribed angles in a circle and they intercept the same arc, what ends up happening is that the angles end up being congruent. So like in this picture, angle D and angle C are both inscribed angles that intercept or shine on arc AB. Because if you look, see how C shines on AB? And then see how D shines on AB? What I like to think about is if C and D were almost 2 spotlights in a theater. They're shining onto the same person. What ends up happening is they end up being the same angle, just from opposite directions. So angle ADB and angle ACB are the same because they both shine onto that arc AB. Think about 2 spotlights shining onto the same person. Okay, they end up being the same. So if AB was 70 degrees, both of these would be 35. Okay, but they have to shine in the same direction on the same arc. That didn't work up here because these were 2 different inscribed angles going in 2 different directions. Okay, example 4 is kind of the same thing. So a lot of times they're going to give you a circle with a lot of stuff and like one beginning part. So this one, it's kind of what should have happened in this one. That T, that dot for T should really be here. T is the center of the circle. So to name 2 pairs of congruent angles, we can look at two angles that shine on the same arc. So what do you think? You can just give me one letter answers. Can you find two inscribed angles that would shine on the same arc? Wouldn't P and Q, they both shine onto RS. So you have this one shining on RS and this one shining on RS. So they're the same. Now it's tricky because we actually have two going in the other direction. Angle S and angle R are also going to be the same. They're going to shine on arc PQ. Like that. Okay. So now let's try and figure everything else out. So the first one says the measure of angle SPR. That's basically angle P. So if you look at in the picture what it shines on, it's an inscribed angle shining on RS. So it's got to be half as big. So it's half of 81. Aaron, what's half of 81? Thank you. Now here's the tricky part. So this one's 41.5, right? The second one says PTQ, which is this guy. Okay, that's the central angle. Before I do that, I should probably go in order. I gotta find arc PQ. So I gotta find this guy. Well, we know what kind of angles would angle T up here be and angle T down here be? Vertical. So if this is 81, wouldn't PQ also be 81? So PQ is 81. That's C. So then this angle here where the T is, that's a central angle. That's also 81 degrees. So it's tricky. If it's a central angle, if it touches the center, it's the same. If it touches the outside of the circle, it's half. PTS would be this central angle. So we got to find PS first. So how big do you think this arc is? What's 180 minus 81? 99. So then PTS, the central angle, is also 99. And then the last one says SPQ, which is that whole arc, and that's 180. Okay, so you got to take your time on some of these problems. There's not a whole lot of work. It's more just looking at it. Is it half? Is it the same? You have to double it. Makes sense. Your homework tonight's a worksheet, so that's a lot easier to deal with. Okay, the last kind of angle is called a circumscribed angle. A circumscribed angle is an angle that is outside the circle and the sides are tangent to the circle. Remember, tangent means it's only going to hit it at one spot. So this one's the hardest kind. The angle is basically outside the circle. angle T. Okay, the measure of this angle formed is half the difference between the two intercepting arcs. I missed a word. If two tangents intersect outside a circle, then the measure of the angle formed is half the difference of the intercepted arcs. So it's half of PQR minus PR. So if this was like, this one's always going to be a major arc the majority of the time. So if this was like 240 and this was 120, this angle T would be half of 240 minus 120. What's 240 minus 120? 120. What's half of 120? 60. Okay, so you have three different kinds of arcs, or angles that we dealt with. We're going to write them on the next page. Okay, so you got to be able to identify. So there's three different kinds. Before we do these two examples, let me show you the three different kinds again. So you have a central angle, which is that kind. Okay, you have central angle, which is that kind. It's the same as the arc. Then it's kind of like you push it back. The second kind is the inscribed, and that's touching the outside of the circle. Okay, and that's half the arc. So that's half of this. So you start off the same, you get pushed back your half, and then the last one is the one that we just did, and that's the crazy one. Okay, that's circumscribed. And that's half, I just call it the big arc, minus the small arc. So see how the angle's kind of moving? And every time the angle moves, it's going to get smaller and smaller and smaller. Okay. So you got to know the difference between these three. This is like your formulas for the second part. Even though there's no actual formulas. So if I want to find angle T here, this 138 is from P to R, which would make PQR on the other side how big? What's a whole circle again? 360. So 360 minus 138. The rest of that's going to be 222. So what I'm going to do, angle T is half of 222 minus 138. Okay, it's always half the other sides. What's 222 minus 138? 84. Thank you. So half of 84 is... Okay. Hold on. So we're going to change B. Instead of just finding the angle T, I'm going to make angle T equal to an algebraic expression. I'm just making this up, so it might not work out. I'm going to make angle T equal to 2x plus 13. This is going to show up on your homework and on the test. Okay, so normally what we would do is the angle is half the difference between the two arcs. So we're going to set it up as 2x plus 13 is half. Now we got to figure out the two arcs. The 232 goes from P to Q to R. So I'm going to take 232 and I'm going to have to subtract what would be the other part of that circle. $128. So I just get subtracted from 360. So this side, you can go ahead and find what the angle should equal. So go ahead and just do the math. 232 minus 128. So 2x plus 13 is half of 104. I'm going to divide 104 by 2. So 2x plus 13 is equal to 52. Now I got to solve that using algebra. So what should I do first? Subtract 13. So 2x equals 39. So x is 19.5. Okay. So you're not always on this kind. There's one problem in the homework where you're going to have to set up an algebra problem. Okay, and on your test. So that's why I wanted to show that. So you still do it the same. You take half the difference, but then you just make that equal to your algebraic expression. I could flip it and give you that as an angle, and this is two expressions. And you would do the same thing. Just subtract, cut in half, and then solve as much algebra as you can. Any questions?